Hello everyone. Welcome to the Global NLP Lab, a place where we discuss the latest in natural language processing in research and in production. Today we're taking a look at the paper Learning to Reason and Memorize with Self-Notes by authors from Meta AI. As we all know, large language models have taken the world by storm. They're useful for various applications such as chatbots, summarization, question answering, and many others. However, one fundamental limitation of large language models is that they have difficulty when dealing with multi-step reasoning problems, and also they have limited memory, meaning that they're unable to recall due to the limited context size of several thousand tokens. They're not able to remember beyond that point. And the authors in this paper propose a mechanism or a way to equip large language models with a scratchpad mechanism that is embedded in the context and helps to guide LLMs to better solve multi-step reasoning problems or problems that require memory. Let's take a look at this paper. So here is what the authors propose fundamentally. Here we have three approaches to kind of embed some sort of an extra memory within the context of the LLM. On the top, we have the vanilla LLM approach where you're having a context and a question as a prompt, and the model is taking this context and question and producing the final answer. To enhance the capacity of the model to produce a better answer, one common way is to add a scratchpad. So instead of outputting the answer straight away, you can request the model to produce some intermediate results. This is related to various similar prompting techniques such as chain of thought, which you might have heard of, and I think I actually made a video about chain of thought on this channel as well in the past. But the basic idea is to produce intermediate information before outputting the final answer, which give the capacity of the model to reason, to perform some intermediate reasoning steps and to recall relevant information before outputting the final answer. This definitely helps a lot. And what the authors of the current paper propose is an approach which they call self-notes. The idea there is you breaking down the context into multiple steps and performing intermediate reasoning and allowing the model to also collect and distill the information several times before having to make the final output decision. To give you an illustration of how this works in practice, here we have a few examples for the task of question answering. The vanilla approach goes like, Mary has the bow is inside the box, the key is inside the box. The question is who has the key? And the answer is Mary has the key. The scratchpad approach augments this with some intermediate reasoning steps such as who has the box? Mary has the box. Who has the key? Mary has the key. The self-notes approach, in contrast, interleaves these reasoning steps within the context. So we have first Mary has the bow is inside the box, and then this scratchpad approach, scratchpad prompt is integrating who has the box, Mary has the box as an intermediate reasoning step. So now we have established that Mary has the box. Then we have another piece of context, which is the key is inside the box. Who has the key? Mary has the key, which is another intermediate step in green over here, produced by self-notes. And then the final question is who has the key? And of course, Mary has the key. We already have that information computed. So this is the basic principle. And the authors of this paper perform a bunch of experiments using the GPT-2 model on using this type of reasoning, comparing the vanilla to the scratchpad approach to the self-notes. Basically, what they find is that self-notes is for sure much better. However, one caveat here is that their best model has to actually be trained on datasets that have been annotated with this self-notes format, which is not ideal if you just want to use an LLM out of the box. Here you actually have to fine-tune the LLM on a suitable dataset. The authors do propose a method for unsupervised fine-tuning using this self-notes format. So in overall, self-notes is an interesting method which equips LLMs with a way to store some extra intermediate memory as part of the context, which is useful for tasks that require multi-step reasoning or tasks that require memory and they have very long contexts and might benefit from having some sort of an intermediate memory mechanism. Self-nodes works better than alternative methods, but it's still limited in the sense of you need to fine-tune on a dataset that has been annotated with a suitable format. But what I find interesting about the paper is that it's definitely focusing on a very important problem with LLMs. Long-term memory, even short-term memory is an issue with LLMs, which needs to be resolved by the community moving forward. And the authors propose a relatively simple mechanism which allows LLMs to have access to some sort of mechanism, a way to store and to retrieve valuable information and memories, which helps to inform future decisions. So that's it for now. Thanks for watching, and I'll talk to you in the next one.